In this section, we're going to talk about quadratic functions in general form. A quadratic function in general form is f of x equals ax squared plus bx plus c, where a, b, and c are just numbers. Of course, a quadratic function is a parabola, and the vertex of the parabola using general form can be found with the little formula negative b over 2a. So when you're trying to find the vertex of a parabola when it's in general form, then you'll use x equals negative b over 2a. That also tells you the, where is it? Well, it also tells you the axis of symmetry. Let's write that down. That would be x equals just negative b over 2a. Now, once you've found the x value of the vertex, you would plug that back into your original function, and that would help you find your y value. And here are some steps you can use to graph quadratic functions when they're in general form. But I'm not going to read through that. If you want to follow them, you can. I'm just going to go ahead and start an example for us. So we're going to graph f of x equals negative x squared plus 4x plus 1. The first thing we want to do is determine if this graph opens up or down. The value of a determines whether it opens up or down. If a is positive, our graph is going to open up. If it's negative, it's going to open down. And so since we're negative here, then our parabola is going to open down, meaning that the vertex is a maximum. Next, we want to find the vertex. So we're going to use x is negative b over 2a. So negative 4 over 2 times negative 1 is 2. So the x value of our vertex is 2. To find the y value, we just plug in to our function. So negative 2 squared plus 4 times 2 plus 1. Notice this is not negative 2 squared, okay? Because that negative is on the outside, then we don't need to put it in parentheses. So we've got negative 2 squared. That gives us a negative 4 plus 8 plus 1. And so that gives us 5. So our vertex is the point 2, 5. I'm going to come over here on the graph and graph that real quick. So there it is. Next, the axis of symmetry. That is negative b over 2a. So we've already found that. Or the x value of the vertex. So x equals 2. And do remember that the axis of symmetry is a vertical line, so you must write it as x equals 2 in order for it to represent a line. And I'm going to come over here and just graph a dashed line there for our axis of symmetry. Next, find the x-intercepts. To do that, we let y be 0. This particular equation is not going to factor, so we're going to use the quadratic formula. I am going to go through and just divide by -1 to get rid of that negative up front. So positive x squared minus 4x minus 1. Really doesn't matter, but okay, so to find our x-intercepts, we've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's 4 plus or minus the square root of 20 over 2. Put that in your calculator. First, you'll say 4 minus the square root of 20 divided by 2, and that gives you negative 0.240 as your first x-intercept. And then we'll say 4 plus the square root of 20 divided by 2, and 4.240 is the next x-intercept. So these aren't going to be perfect, obviously, but I'm going to graph them as close as I can. I think something's a little bit off. Yep, because that first one was supposed to be negative. So there we go. And then we want to find the y-intercept. Remember, to find a y-intercept, we let x be 0. So we'll have y equals negative 0 squared plus 4 times 0 plus 1. It's 1. So the y-intercept is the point 0, 1. And you may notice as you do these more and more, the y-intercept is actually just c. It's always that number right there, if it's in the form ax squared plus bx plus c. So our y-intercept is 0, 1. Since this is a parabola and it's symmetric with respect to that line, x equals 2, then I can go ahead and plot this point over here. Will be on the parabola also. And now we can graph our parabola very carefully. Oof, that was bad. It's a little bit better. Okay. Then we want to identify the domain and range it asks for. So the domain of a parabola is always all real numbers, so negative infinity to infinity. And the range for this one, starting from negative infinity and going up and stopping at 5. So negative infinity to 5, and we put a bracket on the 5 because it is including the point there. Realize that if your parabola opens down, it has a maximum, and that maximum occurs at the vertex where x is negative b over 2a. If your parabola opens up, it has a minimum, and that minimum occurs at the same place where x is negative b over 2a. For example 2, it says, consider the quadratic function 4x squared minus 16x plus 1,000. Determine without graphing whether the function has a minimum value or a maximum value. Okay, we can do that. We look at what is a. A is 4, and a, which is 4, is greater than 0. It's positive. So that means that our parabola opens up. If our parabola opens up, that means that the vertex is a minimum value. And realize if it opens up, yes, you see why it's the minimum there. Okay? It says find the minimum or maximum value and determine whether it occurs. So to find that value, we can find x by using negative b over 2a. So we'd have negative 16 over 2 times 4. And that is negative 2. So that's the x value of our minimum value. And now we need to find the y value. We do that just by plugging back into our original equation. So 4 times negative 2 squared minus 16 times negative 2 plus 1,000. You could put that in your calculator. You get 1,048. So the minimum value is negative 2, 1,048. This problem also wants us to identify the domain and range. Well, the domain is easy. It's a parabola, all real numbers, negative infinity to infinity. The range, we're not going to graph this officially, but just a little sketch. The minimum value was at negative 2, 1,048 it says. So the range is starting at 1,048 and going to infinity. And again, this is something else you can read through for maximizing and minimizing quadratic functions. We've already looked at some examples.